Alright, going to do section 3.2. There was only a few problems on here, but some of you may still be needing those. Number 12 was asked about, and it gave a table, and it said X was 3, 5, 7, 9, 11, 13, and Y was 0, 2, 3, 6, 9, 11, and it said draw a scattergram. So 3 was 0, 5 was 2, 7 was 3, 9 was 6, 11 was 9, and 13 was 11. And select 2 points from the scattergram and find an equation of the line containing the 2 points. So if I were to kind of roughly draw a line, it could pick either one of those, and yeah, I'll take the second one, which was 5, 2, and one of the last ones, how about 13, 11, and change in Y is 9, change in X is 8, so I'm going to write Y equals change in Y over change in X times X plus, if I put 5 in here, I get 45 eighths plus something has got to be 2. Well, 16 eighths would be 2, so there's an extra, say 16 from 45 is 39, 29, so there's an extra 29 eighths I'd have to get rid of, which means this would cross at negative 29 eighths with negative 3 and 5 eighths, which is somewhere down here, so that's a reasonable. So here's negative 29 eighths. There's my model. Graph the line found on the scattergram. So negative 29 eighths going up 9 eighths, and I've kind of sketched what I'm going to do because I hit the points already. Use a graphing line calculator to find the line of best fit, and to do that, there's several of them, but first we got to go put the information in. So list 1, clear. List 2, clear. And I got 3, 5, 7, 9, 11, 13. And for the Y's, I got 0, 2, 3, 6, 9, and 11. And stat, calculate. I'll do the linear regression. That's what most people will do on list 1. List 1, comma, list 2, comma, put it into Y variables. So I push variables, Y variables, variables, Y variables, and then select that and select Y1. Press enter, and it's come up with the equation that has a slope of 1.129 roughly, and I had 9 eighths, which is 1.125. Very similar slopes, and the calculator got a y-intercept of negative 3.86. I got negative, let's see, 29 divided by 8 is negative 3. I had a negative 3.625. Similar, so I got close to what the calculator got just by my rough estimate there, and using 2 points. And draw the scattergram and graph the line. So to draw the scatter plot, I would have to go second, stat plot, turn on one of them. I chose number 1 with a scatter plot, list 1 and list 2. Then I can go zoom 9 to get the data, and there's the line. Came close to that one and close to that one. That's the ones I chose to find my equation of the line. And I could actually type in my equation here. I had parenthesis 9 divided by 8, close parenthesis, x minus 29, parenthesis 29 divided by 8, close parenthesis. And I'll graph that, so I'll have that one. And the other one, you notice it's really close to the last one. Okay, so that's 12. 15 is asking you to do basically the same thing. So I think if you want to see how to do 12, you can do 15. 17 now is asking you to do that same kind of stuff with the candy bar data. So I don't think I need to do it either. And I did that one in class. And 19 says to do it with video games, so let's just do it. I'll put the data in for 19. So stat, edit, go to list 1, clear it, come down, go over to list 2 and up on the name, clear, come down. Now put in the data, 0, 0, 2, 3, 3, 5, 8, 8, 10, 12. The data to go with that, the hours of video games, the grade point average, 3.49, 3.05, 3.24, 2.82, 3.19, 2.78, 2.31, 2.54, 2.03, 2.51. Do I have the same numbers in each list? Looks like it. So now I should be able to, if I quit, I already have, if I go second, enter, I have linear regression of using list 1 and list 2 through the Y1, and I get a linear model. That would be it. And let's see, what are we supposed to do? Explain why the number of hours spent playing video games is independent variable and the cumulative grade point is the dependent. The reason we have it as the independent is the number of hours. We don't control that, but the grade point might be dependent on how many hours. And that's what we're guessing, and so that's why the hours is independent. They get to choose that. Their grade point is a result of that. So it depends on the A. Draw a scattergram. So second, stat plot. We still have 1 on with list 1 and 2. So if I just go zoom 9, that should mark it. And I've already used graphing to find the line of best fit. Oh, it's drawing the other lines here. So I should go to y equals and get rid of that second one. And this is the line of best fit that the calculator got. Express the model using function notation. So now to write this in function notation, slide this up. The grade point as a function of the number of hours is, let's see here, go to, we can quit and take a look here. It says negative 0.094x plus 3.27. Okay? So, and what this is saying is that for 0 hours of playing video games, they get a grade point of 3.27. For 1 hour, it will go down 0.094. For 2 hours, it go down twice that much, and 3 goes down that 3 times that much. Interpret the slope. Oh, so I just did. That was D. Predict the grade point average who plays video games for 8 hours. So I can go to my graph. Let's go to the table, and I'll just work my way up until I get to 8 hours. You might have to redo your table set, but 8 hours, it says they're going to get a grade point of 2.52. The grade at 8 hours is 2.52. How many hours a week of video claim do you need the students whose grade point is 2.4? Well, we can just go back up the table or down the table and see where 2.4 is. Looks like it's around 9 to 9.5 will give us something around 2.4. We could also write the equation 2.4 equals negative 0.094 x plus 3.27. Subtract 3.27 from both sides, divided by 0.094, and we would get an answer. So that's 2.4 minus 3.27, wrong screen. 2.4 minus 3.27 divided by divided by negative 0.094, and it says about 9.25 hours of video game playing. So that was number 19. Okay. 21 is a similar type problem, height versus head circumference. And it's going through the same kinds of things. So if you can do 12 and 19, you'll be in pretty good shape to be able to do 21 and or the other problems on 3, 2. Okay.